in this problem, we're told there's this blind taste test where people are asked to test brand A, brand B, which one do they prefer. They're randomly told to drink this type first, then followed by the next type or brand, and then disclose which one they prefer. And the results of the taste test indicate that 45 of 100 individuals prefer brand A. So in this first part, we're going to conduct a hypothesis test, and this is kind of a little different here because we're not going ahead and stating the proportion. Instead, we're told to try these different proportions, 0.34 to 0.56. Okay, so to do a hypothesis test like this in our calculator, and somewhere it says preferably use technology. So to do this hypothesis test regarding a population proportion, we're going to go to Stat, scroll over to Test, and we're going to select number 5, the one proportion z-test, the hypothesis test for proportions. I've already started some of this here, but notice I've put here for p sub 0, I've put 0.34. That's the first of this long list I'm asked to test. 45 of the 100 individuals preferred the brand A, so that's why you see these values here. And we're not told less than or greater than, so we can just use, well, actually we are told right here, just different from p sub 0. So that's another way I could confirm that I'm selecting this two-tailed test. I'm just going to choose to calculate. Draw is kind of neat though if you ever want to try that. So it gives you more of the picture instead of just like you can actually see the tail end. Make sure it's on the right, the left, or two-tailed. But what I'm trying to find here is what is p, the p-value, when our level of significance is 0.05. And if this is less than 0.05, then I reject the null hypothesis. So in other words, I would reject the null hypothesis for p sub 0 equal to 0.34. So I'm going to repeat this process until I do not reject the null hypothesis by coming back to Stat, Test, number 5, and I'll continue to change the p sub 0 value, the proportion value, throughout this list. Nothing else changes. And I'm waiting until p, my p-value, becomes greater than 0.05. Okay, so still not yet. Okay, here at this point, it finally becomes greater than 0.05. We've got a p-value that, in other words, tells us it's no longer significant. So that's going to be the first proportion, okay, and I continue through this list, ideally, but I'm going to kind of speculate, okay. I'm going to test some further down the list just to save some time. So let's try like 0.53, a little bit further down the list. Okay, notice p is still greater than 0.05. Let's try 0.54. So still greater, I would still continue to not, I would not reject the null hypothesis at this point. All right, that was 0.54. Oops. Okay, here I would reject. So the last value of the proportion I would reject was 0.54. And everything in between there I would reject. If you really want to see, you could go through and type in every value, but everything in between 0.36 to 0.54 as far as a proportion goes, does not meet that level of significance. So I would not reject the null hypothesis. Now, next we're going to construct a 95% confidence interval And we're going to do this with the calculator to obtain a confidence interval for a population proportion. To do that, we go to Stat, we go back to Test, and we're going to scroll down or up until we get to choice A, which is one proportion Z interval. Okay, so at this point, notice that some of these values have already been substituted over here. I've got 45 of the 100 individuals said they prefer brand A. I also have a C level of 0.95 that's given here in part B. And let's calculate. So here is my confidence interval. Lower bound to 3 decimal places and upper bound to 3 decimal places. And notice that this lower and upper bound also captures these P or proportions, P sub zeros that we did not reject. Okay, so that would have been another way, actually a little bit quicker way, to find which of those proportions we would not reject. So in this last part, we're asked to change the significance level to make it even more significant, I guess you could say, because this is a smaller p-value, 0.01. It's the equivalent of a 99% confidence level. Okay, so what would happen to the range of values for p sub 0, for which the null hypothesis is not rejected? Well, you could go through pretty quickly here and determine that. So let's do that. I'm going to go to choice A, and I'm just going to change my confidence level to 0.99. And notice that the lower bound is lower than it was before. The upper bound is higher than it was before. So the range of values increased because the corresponding confidence interval increased. And again, we could just confirm that pretty quickly here. And if you think that, like putting this back into the big picture, if we want to be more, I guess you could say more confident, 99% confident that this interval captures our true population proportion, we need to increase its size.